Okay, guys, so over the next couple weeks, we are going to take sort of the most important information from Unit 10. Our Unit 10 is all about right triangles specifically. So we're going to focus on, first, we're going to do some review of Pythagorean theorem, and then really what we're going to spend our time on is sort of the basics of trigonometry. So this video is simply going to be a review of the Pythagorean theorem. So what you need to remember is that the Pythagorean theorem only works for right triangles, and it's a squared plus b squared equals c squared. The most important thing here is to remember where C is located. C has to be on the hypotenuse. Find your right angle, go across, that's your hypotenuse. C must be in the correct spot. Your A and B values, quite frankly, you can trade them out, right? I could switch A and B and this would all still work the same. But you must have that hypotenuse in the correct spot in order for this to work. So first thing we're going to do is just take a look at a couple quick pictures and review the Pythagorean theorem. So when I look at my picture here, I see that my x is on that hypotenuse, right? So 10 and 5 are my two legs. That means it doesn't matter whether I put the 10 first or the 5 first, as long as I'm putting the x in for letter C. So I might have 10 squared plus 5 squared, and we're going to be equal to x squared. So 10 squared is 100, 5 squared is 25, still equal to x squared. 100 plus 25 is 125, we're equal to x squared. And then the key is, I don't want x squared, I want x. So you have to square root both sides of your equation. Once you square roots, just like we did in the previous unit, if you're taking the square root and it's a perfect square, great, get your whole number. If you're taking a square root and it's not a perfect square, you should use your factor tree to break that down. So you can do that off to the side, piece of scratch paper, write in your problem, whatever you like, and use that to simplify. If you break down 125, you're going to end up getting a 5 square root 5. And then you also want to get your decimal value. So again, my recommendation is type the square root of 125 in your calculator, just in case perhaps you made an error when you simplified. And the square root of 125 to the nearest tenth, meaning one decimal place, is 11.2. So those are my two answers. Okay. If I take the same approach to question 2, again, here's my right angle. I go across. This is my hypotenuse, 12. The x and the 8, again, doesn't matter which one goes first or second. I have a habit that if I'm finding one of my legs, I tend to put the x value first, but it doesn't matter. So I'm going to say x squared plus 8 squared. You might have 8 squared plus x squared. Again, it's good either way, as long as we are equal to 12 squared. So we need to go through here. Perfect squares, 8 squared is 64. 12 squared is 144. And so now I need to get my x squared by itself. So you're going to need to subtract 64 from both sides. And so when we do that, we get our x squared equal to 80. Okay. Take the square root of both sides of your equation. Again, break down that 80 using a factor tree. When I do that, I'm going to get 4 square root 5. And as a decimal, this would be 8.9. Okay. If you want to do a quick Pythagorean theorem problem on your own, hit pause on the video and do number 3 yourself. And then we'll just check our answer to 3. So here I have x squared plus 7 squared equals 21 squared. 7 squared gives me 49. 21 squared gives me 441. You would subtract that 49 from both sides. That gives me 392. Take the square root, we get 14 square root 2, or a decimal of 19.8. So this is sort of the Pythagorean theorem that we did previously. We've used it here and there throughout the year. We want to look at Pythagorean theorem, and all we want to do is just look at some slightly elevated questions for Pythagorean theorem. What happens if it's just not a single triangle? So for example, what's in front of you here is a trapezoid. But notice they've marked the left and the right sides of that trapezoid the same. What you should notice is that by doing that, and if you sort of bring those lines down inside where they have the letter X, what we have is a triangle on the left, a triangle on the right, and a rectangle in the middle. And so what we need to remember about rectangles is that the top and bottom of a rectangle are the same. So if the top of this rectangle is 9, the bottom of this rectangle has to be 9. And so if I do 15 minus 9, that's going to give me a value of 6, meaning that's what's left. But understand there are 2 pieces. Now the left and the right sides here match. So if I divide this by 2, that's going to give me 3. And that means the bottom of each one of these triangles is 3. 3 plus 9 plus 3 is still the 15 to go the whole way from left to right. But what that does now is it gives me this right triangle, or the same one over on the other side, to say that my x squared plus 3 squared equals 5 squared. And so now it's just using that Pythagorean theorem. So x squared plus 9 equals 25. If you subtract 9, you're going to get that x squared is equal to 16. And so when I square root this, 16 is a perfect square. And so x is equal to that whole value of 4. Okay. And so I'm going to take that same approach and I'm going to apply it now to this trapezoid. This time they don't necessarily have it separated, but that doesn't mean that I can't separate it myself. I can go in here and I can draw in that vertical line. I can sort of make my triangle, and we can remember that if I have a rectangle, the left and right sides are the same. The top and bottom are the same, right? And if the whole bottom was 12, 12 minus 8 also gives me 4. 4 plus 8 goes back to being 12. It's okay that this 4 and this 4 don't look to be the same size. Remember, pictures are not always drawn to scale. What we do have here, though, is that 4 squared plus 4 squared now equals x squared, since x is on the hypotenuse of that triangle. 4 squared is 16. So I need both of those. 16 and 16 is 32. And the last thing we're going to do is take a square root. Break down your 32. You would get 4 square root 2. And then also take the square root on a calculator. And as a decimal here, I'm looking at a 5.7. Okay, so again, just a quick review, Pythagorean theorem, make sure you're putting everything in the correct spot.